Okay, this is lesson, I guess we can call it Unit 5, solved by graphing. And let's solve it quadratic equations. And we'll call solve learning goal. Learning goal, I can solve quadratic equations by graphing. What does it mean to solve a quadratic equation? Okay, it means the roots of an equation is the value where the parabola intersects the x-axis. Zeros is the same as the root, so we'll use those terms interchangeably. Zeros and root. What does that mean? That means if I have a parabola, solving it is finding these points where x equals, what is x? Where y equals 0. See, it doesn't go up or down. We're trying to find that. That's what it means to solve the quadratic equation. So let's write that down. To solve the quadratic equation, we find what x is when y equals 0. Just notice how we have two answers? Okay, graph the following equations. This is example 1. Graph the following equations and determine the roots for each. So what does that mean? Graph? Well, first of all, what does it mean to solve the roots? It means what's y? Y equals what? When x equals 0. So what does that mean? So let's graph it. First of all, we need to...
Please excuse this interruption. Mr. Smith's students, please report to your classroom immediately. That's Mr. Smith's students, please make your way to your classroom immediately. Thank you.
Sorry about that, people. Clear pen markings. Okay, at the zeros or root of the equation, y equals 0. So 0 equals that. Complete the square. So let's complete the square. We all know how to complete the square, basically. We separate this minus 8 out here. We have a space. See this x squared plus 6x? That's just from there. We add and subtract a number, a c value. C is equal to, take the 6 over 2 squared equals 3 squared, which is equal to 9. That's why we added 9 and subtracted 9. Cancel. Whoops. Okay. And we bring this 9 out. This becomes our x minus 3 squared. This minus 9, we bring it outside the brackets. And then minus 9 minus 8 is equal to 17. Now at this stage, I expect you to know how to graph it. So how do we graph it? Well, this 17 means the vertex moves down 17 units. And this minus 3 means it moves to the right 3 units. Then we just graph it. We use our 1, 3, 5, and we find basically where it hits the x-intercept. 1, 2, 3, 4, 5, 6, 7, 8. Whoops. 1, 2, 3, 4, 5, 6, 7, 8, 9. Basically, I put it into Desmos, and I found where does y equal 0, and it occurs at 7.123 and negative 1.123. Okay, not ideal to graph, by the way. You should be seeing the drawbacks of graphing right about now. Let's try example 2. It only works well when we have integers. See here we have decimals, but graphing doesn't really work great. Like, what's 0.123? We don't know, really. It's not easy to find out. All right, so Graph the following equations and determine the roots for each. Okay, what do we have to do? We have to complete the square. At the zeros, or roots, this is the same thing. What does that mean? That's just telling me that what the answer is when y equals 0. That's all. Y equals 0. So we just substitute. What's x when y is 0? Well, we can solve by graphing, but notice that this is a perfect square. That's a perfect square. That's a perfect square. By the way, if we tried completing the square, we'd get the following. We'd get, let's say I didn't know it was a perfect square. I'd get x squared minus 6x plus 9. I'd take my c value, divide 6 by 2, plus 9 minus 9. Guess what? This minus 9 and plus 9 cross out. That, we already built a perfect square. By the way, it's exactly the same thing. So, it is a perfect square. So we can just graph it as x minus 3. This whole thing is x minus 3 squared, which means it moves here. Notice I only have one answer. Remember we had two answers? Two answers all over the place. Here we only have one answer. So sometimes when we solve our quadratic equations, we can have one answer or two answers so far. Let's look at example 3. Graph the following equations and determine the roots. Once again, I'm just going to state the same thing. At the zeros or root of the equation, y equals 0. 0 equals, by the way, it's already in vertex form. So when when y is 0, what's x? And we can solve by graphing. We'll just graph this equation. This minus 1 means it moves 1 unit and moves up 3 units. That's from that 3. So here we go, right? Positive, positive 3. And we graph it. Now, when is this graph? When is y equal to 0? It never is. So guess what that means? That means there's no solution. There is never a point in time when y is never 0. In fact, our range starts at the value of 3. Okay.